intermediate value theorem, we have an intermediate value theorem for derivatives and for the functions. And I'm just going to refresh your memory. Now, here's the deal, guys. You have to have a continuous function on a closed interval. And all it says is if you have, like, a here, then this y value is f of a. And then you have b over here, then this y value is f of b. So, for instance, if f of a were -2 and this were equal to 10, okay? Come on. Okay. If it were -2 to 10, then what would happen, this function, if I have a continuous function closed interval, it will pick up all values between -2 and 10. That's all it says. So if you want to say, I want to say that the function is 5, I know it's 5 because the one value is -2 and the other is 10. It has to pick up all of them. That's all it says. So it picks up all values. And the reason I'm hitting on it is because it's been on the exam. Or f of a to f of b. Pardon? Oh. Now, the most important one is the 0, because that's usually how we measure our weather here in Minnesota. We say, well, it's 20 below and it's going to get to be 10, so someplace in time is going to be 0 degrees, right? And that's all it says. So it's an important theorem, and sometimes it's just hard to recognize. But they'll give you a closed interval, and all you would have to do is evaluate your function at the two endpoints, and it will say, show that the function goes through 5, for instance. And you'd find that f of one endpoint was -2, f of the other endpoint is 10, and it just picks up that value in between them. And all this part for the derivatives is because a derivative is a function. I have the intermediate value theorem for derivatives. So if the derivative is -2 and it goes to +10, then the derivative will be somewhere in between -2 and 10. It has to hit on those values. So someplace the derivative would have to be what? 0. The derivative being 0 is important. So someplace the derivative equals 0. Matter of fact, if the derivative is 0, what does that tell you about the function? It tells you something. Is it what? I could possibly have something like this, or something like this. It's a candidate. So if the derivative is 0, I have a possible maximum or minimum of my function. So that's why the intermediate value theorem is important. So if my derivative changes sign, then I know that. So when we get into finding max and mins, we'll be doing that. Now, it's not guaranteeing that you have a max and min. It guarantees a horizontal tangent. Because what if I do this function? What's true here? The derivative is 0. That's a horizontal tangent, but it's not a max or min. But these are places we're going to look for. So that's the reason why this is important. We'll hit on it again. Would it always be like a horizontal tangent, you mean? Right, if it just like you called it, you sort of says like it bounces off of there, yes. Now, can a tangent line cross the curve? So what if I took, for instance, the sine function? Obviously, at maximum, the derivative is 0. What if I did my tangent here? It touches just at that one place. However, does it ever cross the curve again? Yeah. People want to say it only touches the curve once. That is not a true statement. That is an easy question for them to actually get at on the exam in multiple choice. You only have to look in we call this the neighborhood, close to that point. It'll only touch in that little neighborhood in one place. But later on, it might cross the curve. So I don't know. So that's a tricky little subtlety too. And that's all I have to say about the intermediate value theorem. Are there questions on homework, or do you just want to work? I do have the solutions in here. Yeah, we gotta work. I do have the solutions in here. And then I will update Schoology